Okay, good evening. Let's start with traditional question about sound and video. Okay, if everything is okay, let's start with homework about strings. So the first homework was about taking some user input, name and surname, with some that may be a little bit incorrect. So we should correct the user input and make username capitalized and surname in uppercase. So here are two options how to perform this homework. The first one is, let's say, a little bit hard-coded in the terms that we can take only name and surname, only one surname. And so that just can perform only the first option. But if we want to achieve result, so user can input multiple surnames, and here we divide them with this hyphens. We need a little to perform this task in a little bit different manner. So the first option is just taking name and surname. Second one is more complicated, and it will use split. So let's perform the more advanced option when we can process multiple surnames. So, okay, let's start with taking user input. So we already know how to do it. So to here, let's write some text, descriptive text about please enter name and surname. And here we need to use a function next to get the whole line of text. So let's call it user input. Okay, after that we can close scanner, so we do not need it anymore. Okay, so about the main algorithm. So we're taking full user input, and we need, and this one may have a lot of spaces before and after. So what we need to do before starting to process everything is to trim user input. So I have shown on previous lesson about cleaning user input from extra spaces that can be before and after text. So for this we have a special function called trim. So this will remove these extra spaces before and after. Okay, so and we can reassign that result of trim back to user input variables. So just not create an extra variables. So trim returns us because string is immutable. This trim will not change the original string, but will return us a new string. So here it is. Trim will return us a new string that will not contain these extra spaces before and after. We can assign it to different variable. to a new variable. But also we can to do it like this. We can assign the result in the same variable, just not create some new variables. Okay, after that, we need to process name and surnames separately. So now let's split the input with by spaces. So in this case, we will get separate all the words separately. So let's make this array. Let's name it simply words. So for now, let's just print this array. So just let's look what we have here inside. So I will remove this a little bit later. For now, let's look what do we have after splitting. So I will run, and here I'll just copy this input. Unfortunately, this is we got here a new line, so we should enter everything in one line. So like this, John Lemon Hook. Okay. So after splitting, we have not really great results. So let's look why such things happen after a split. So after a split, okay, not really here. Let's look what we have before a trim. So before a trim, we have only John. Okay. But if we will try that way, okay. If next doesn't work, let's try with next line. Oh, okay. So next somehow brings us just next word, but if we use next line, this will bring us the whole line before a new line. So here finally we got this this input string with spaces before. Okay, let's try one more time like this. Oh, okay, finally we got this extra input with extra spaces inside and before and after. So after trim, we have removed the spaces before and after. Now after split, let's look what we have here. John, lemon, space, space, and hook. So what's the here it is this special problems with split functions. So we have noticed on a previous lesson when we have used the split, we have somehow very special results. So when we have tried to split something that doesn't have any match, we got original string, but here's a little bit another case. We have just extra spaces inside our string, and when we split by space, these spaces that are between spaces are also become here in an output. So we can just sometimes we can just simply ignore these white spaces, and the other option is to limit this split function with here second parameter called limit. So when we're using this limit, our when we're using this limit, we can limit this extra empty strings. So, okay, maybe we can, evaluate. So here in debug, we can try some extra parameters of this split. So let's look how this result will differ. So if these results cannot be anyhow filtered, we can just simply ignore them. So we should beware of this empty results. So we will so if we know the length of each word, so if length of some word is bigger than 0, this is username or surname. But if we have this just empty result here, so length of this string will be 0, so we can just simply ignore it. So okay, the main idea that I wanted you to achieve, that we can not only process everything in a loop, we can we know that username should be processed in another way than surname. So, but we know that name stands on a very first position of the centered string. So after a split, name will be here inside this words array on a 0th position. So words 0 will be on the first on the 0th position. So let's move it to the separate variable called user name. Okay, what we should perform next with this username? So this can have some uppercase letters in some random places. So to achieve all letters in an lowercase except the first one, we can use we should split this one into two parts, and so first letter and all other letters. How can we achieve this? We can use substring. So username substring from 0 to 1, this will be first name letter, and everything other, so starting from 1, will be remaining name letters. So here, when we use substring with only one parameter, so this will so we will get substring from this index till the finish. if we use two parameters, so this will mean from and to. So from 0 till 1, this will be the first letter. So from 1, so if we have this parameter only 1, so it will be all the remaining letters except first. Okay, so what should we do with first letter? First name letter is equal to first name letter to uppercase. So we have here string only with first letter. We should always do it uppercase. And remaining name letters, we should always take them to lowercase. And therefore, we will achieve that first letter will be in uppercase, all other letters in lowercase. So if they were in lowercase, that's not a problem. So taking lowercase letters to lowercase will not toggle them anyhow. So they will still remain in lowercase. The same with first letter which we are forcedly performing uppercase. After we have these two strings, we can concatenate them into a new string. Let's call it formatted first name, and this is first name letter plus remaining name letters. So here we will get everything this name of user processed. So if we had something like this before, we will have something like this after. Okay, we can try. So after a trim, we have this user input. We have split it, and now, so here is the words array. So on the zeroth position, we have user name. Now let's split this John on first name and remaining letters. So here they are. First name letter is J, and here are remaining name letters. Now we will take this first name letter to uppercase. You see this is changed to uppercase, and this will now become in lowercase. Now we can put them together simply by concatenating strings. We have done this multiple times before when we have formatted our output. Okay, now we have this formatted first name. So user first name now is fully formatted. So before going to process all other user surname, so please rewrite this and let me know when you are done with it. So we will continue with surname when we will get a fully processed code of user first name. Are you still writing code, or we can continue? Okay, is it now clear with how we process the first name? So, as I have seen from homeworks, mostly this was done. Okay, if it's clear, now let's uh, take the last part about creating this extra surname. So the idea was, so we will, just because we don't know how much uh, this last name parts user will enter, we will use a loop. And here, just because this array words will contain the username first name on the zeroth position, we have already processed this. So just for this loop, we should not always start this from the first zeroth position. So we can start it from 1, for example. Because our first name is already processed, we can now concentrate only on processing last name. Okay, so now in loop, let's take next part of this his surname, and what we should do here, we should make it ultimately uppercase. So let's take each next. Now we should check. Uh, just because we have seen before, we can have empty words here inside. To check if this string is not empty, what we can write some if here. So if word length is more than 0, so empty array will have empty string will have length of 0. But if this is not empty, it will have some positive length that is not 0. Okay, now we here inside this if we know that this part of surname be will, conti will consist from some text. And now let's create this uppercase, just like we have done before, just for one letter. Now we will make this surname part uh, all in uppercase. Now, okay, let's. But the problem here, we have created this word, this part of surname in uppercase, but we need somehow to concatenate these parts. Now, okay, let's create just like we have calculated some of array values. Here we calculate just a part of result, but we should put this inside some other. Uh, we should sum this with another string. So let's create some string surname and let's make it empty. So when we have processed a part of a surname, let's do like this. So here we will concatenate a part of a surname into variable called surname. And now after when we have processed all these parts of surname, we have both first name and concatenated surname. Okay, let's put more extra this hyphen after a part of surname. So we will change this a little bit later. Just now, let's just create an overall solution. So complete, let's call it full name. So full name is first name plus second name or surname. So it is formatted first name plus surname. And here we had extra requirement. We should use these quotes before and after. So let's concatenate this with quotes. Now let's try to print this full name that we got. So still the same word, name and surname. And look what we got here. Okay, we need space before name and surname. One more time. Oh, okay. Now we have something that looks like more or less looking like result. So, okay, now let's rewrite this part, and later we will think about this last unnecessary minus sign. So please rewrite this part and let me know when you are done with this. Okay, now let's debug what happens here. So entering the same. So I have put breakpoint after we already formatted the first name. So this surname variable will uh, work like some kind of aggregating string. So we can just like we can count numbers inside one variable, and this will be a sum. We can perform the same operation with string. So we have already work concatenating strings all the time, but the main idea is that we can do it inside a loop. So just like we have done with numbers when we counted them into a sum variable, this sum initial value was 0. Here we're using empty string, and we will concatenate formatted parts of a surname inside of this. So here we start with e is equal to 1. So we will not process user first name here, but we will start with first part of surname. So on the first iteration, we have word lemon. So this is a part of surname. Okay, we have checked that this part is not empty. Its length is more than 0. And now we have created this in uppercase. Now we can put this into result. So this surname is like a result. Done this, and look, we have this lemon and minus sign here already in result. So next part of his surname will be concatenated here to this result. Okay, let's take next word. It is empty. Okay, we should not process this. So this check did not pass and nothing happened. Taking next, again we have empty parts here. So this check will not pass, so we are doing nothing here. Okay, now we have the last part of surname. Here the check will pass. We will create this part to uppercase, and we will concatenate this to result. Okay, now we have this result. So the last thing that we need to perform is to take this surname, take formatted first name, concatenate with surname, and just put extra space between them. So this is now our last name, this full name. So here we have both first name, space, and formatted last name. So the only problem we got here is this extra minus here. So how can we remove this? First option, we can append this minus sign here separately only within a condition if this appending part is last. So if we assume that this part is last processing part of his surname, we should not append this. But as you have seen before, we can have these extra empty strings. So the better option here may be another. So we can have this surname look like here, look like it is now, but we can take only every symbol from this except last symbol. So how can we do it? We can do it with a well-known operation substring. So we can take surname from 0 till surname length minus 2. Why? Let's try, and then let's look why minus 2 here. Sorry, not minus 2, but minus 1 here. Okay, so looks like good now. Why minus 1 here? Because so length so from 0 to length will be actually the same string. So if we are taking substring from start till the end, it will be the same string. So, but if we are calculating this end index by length -1, so this will mean we're taking from 0 till previously to last symbol. And we will get the same string but without a last symbol. So here it is surname, lemon minus hook minus. And when we are taking this substring from start till till the last symbol -1, we will get the same but without the last symbol. And now we have printed this. So looks like we have achieved the results that we need. So how we achieved this? We have achieved this with taking a part of a surname, not all surname, but till the previous to last symbol. So we can say here we're removing here we are removing last symbol. But this should work only if we have more than one part of a surname. So we should take this part of a code under a condition. So if words length is more than 2, only within this condition. So if we have only if we have more than one surname, we should perform this. No, no. We need to do it all the time. Even if we have one surname, one part of surname, we will still append this minus sign. So okay, this should happen without any condition. So please rewrite this part, this one line of code and the comment. Okay, it is here more or less clear how we have processed name and surname. Or maybe you still have some questions. So here we used lowercase, uppercase. Here we have hardly used substrings. So here we have examples of taking substring from and to, and from some index till the end. And here we have calculated this last index from the length of a string. So if we need to limit the string to some symbols except some last symbols, we're using this approach. So okay, if it's clear, let's move to second homework about calculate words. Okay, here we have a lot of ways to perform this task. So count the given words. So the easiest way by how we already know how to do it, it is using a split. So if we are splitting this whole string by some words, we can analyze the length of this array. So let's just simply print how much the length of this. Sorry. So what we have done here, we have splitted this array by word the. So in results we will have, for example, this part until the word the, and all the rest part until the next word the. So we can analyze how much parts do we have. So if this string, initial string, does not contain any words the, result will be original string. So this array will consist only of one element with original string. But if we have, for example, one the word inside, we will have this array of length 2 because we will some part of text before the and some part after the. So let's imagine some extra string. So here we have, I don't know, some extra numbers going in sequence, and they are divided by spaces. So if we, for example, splitting this string by space, we will have result 3 because here's the first splitted part, here's the second, and here's the third. And how much spaces do we have here? We have 2 spaces. If we have here one more word split after a space, we have result after split 1, 2, 3, 4, and we have 3 spaces. So the idea was that number of words that we're searching will be number of splitted parts minus 1. So here will be words that are before and after searching part, and so the count of searching parts will be number of this splitted part minus 1. So count is equal to length minus 1. Okay, let's put it in more brackets. So count is equal to 6. Let's calculate how much do we have them. So 1, second here, third, fourth, fifth, sixth, and okay. So looks like we have calculated this correctly. So please rewrite these 2 lines of code and tell me when you will achieve the same result. So do you have questions on this, how we have counted words by using split? So let's say uh, this this is a documented feature. So uh, split is meant to split the text by some delimiter, but we can count how much words do we have in a string by analyzing the results of how much split parts do we have. So this is a little bit tricky, but this works. And now I will show you the second approach when we uh, will find all the positions of this word. So the main idea was using index of will give us the first occurrence, only the first. And the idea was, so we are finding the first match, and then we increase the counter or somehow remember this position, and then we need to analyze only the rest part of a string, ignoring that we have here before. So we can do it okay in multiple ways, but um, let's do it in the most simple way with a while loop. So text index of the. So we already know how to do it. The, getting the first index of matching word. Index of word. So if we have this index, if this index is greater than -1, so if we do not have this word in a text, this will be -1. But if this is more than -1 or is not equal to -1, so while index of word is not -1, let's do the following things. So here let's create a counter that is equal to 0. So we have once used the counter to count some positive or negative values inside an array. So now we will use counter to count how much words do we have. So initially this will be 0. So if we trapped here inside this while loop, we're increasing this counter by 1. So we can use plus plus or counter plus 1. That's the same. And what we need to do next, we should remove this part of a string. So we should ignore this. So index of the will give us this here when the cursor where I have pointer now. So this will give us the place when this word starts. And here's a very important moment. If we remove this part, okay, let me remove this. And when we will analyze the same, the rest of string again, so we will have this word there again. So the trick was here. Now let's say the text is equal substring from index of word till the finish. So if we are doing this, we are actually removing the text that is written before the first match. So we are actually removing this. And here's the important moment. So we should not start really from this place to search again. We need to remove one extra symbol. So when we remove this and try to find the next word the, this will not match. So we will find this one. And again, we will remove this part of a text and remove this first symbol. So it is necessary not to loop eternally. So we need to ignore this found word and search to the next, to this one. And now, after so we, because our loop is dependent on this variable, we need to search next next match. So here, index of word is the same operation. So if we will find the next index of the, so if this number will be positive, so we will go inside this while loop again. If this will not be positive, so if this will be -1, so we will go out of the loop. Now let's see how much we have counted these words. Okay, let me understand the question. Okay, I understood about these indexes, so we will adjust this. So now what I have done, I have only counted this word. So I just wanted to show the base principle, how we will process this text. So please rewrite this part. So we will work with this, we will rework this a little bit. For now, just let's take this part and analyze how this works. And well, you see that we have the same counter. So our approach with split was correct. So please copy paste this code and please give me know when it is done. So we will a little bit rework this after. Okay, so here I will on the first so here I will as a first instruction I will print this index of word. Okay, I will just print this and with extra space, so just to show. Later we will store them in extra variable. So now these indexes will not be really correct, because they will be taken from the part of a string, not from the original string. So how to achieve these correct indexes? Here are multiple ways. For example, we can take the previous index and put and sum these together. So they will. So so for example, we have here the first index of z. So we have removed this part. So we can store by a number here. So this will be the first match on a 36th index. So we are removing this. And now we start counting till next word z. And here we will have, so we have found that this is on index 59, starting from here, so not from the original. So we can now sum this together, and we'll get this index of this second match here in the right position. So let's try to do it. This is just one of approaches. Okay, now let's create one more variable. So here we will store previous index. So from the start it will be 0, and after but when we will but when we should print this found index, we should calculate this with the found one, the new. So here we will have previous index plus the found one, and this one, sorry, not really this. So previous index will be, oh no, this not this not really. Okay, that's a good point, how to calculate this correctly. Okay, let's think one more time. So when to store this previous index? So once we have calculated this, so once we have calculated this, looks like we need this here. But here we will print this previous index plus index of word. Let's run once again. Okay, so this will not work also. Okay, so Lima, you have found a really great idea. But okay, so looks like this relative indexes will not work. Okay, but we can do this in another way. So we can store this a little bit another. So instead of using counter, anyway, we do not need this anymore. Let's create an awesome list. So once we have done this very great collection, let's put these indexes inside collection. Add this found index. And but before putting this, we need to take the last one and then okay. Looks like here. So if we have some records in our awesome list already, let's take it from our list, else let them be 0. And now let's add previous plus found index. And after this we can print our awesome list. Well, now that looks correct. Do you agree on this? At least when we are looking on results. So let me show you the meaning of this collection. So let's run debug and look on the result, on what do we have here. So from the start our collection is empty. So the meaning of this collection is that we can easily add and get some elements without keeping in mind how much of them we already have. So we are not limited by length when we have array. So okay, we have found the first index. Now let's understand, do we have some previous word there found? So here I know that we will store the found indexes in our awesome list. So here is just check. Do we have some previous value in our awesome list? Looks like we do not have because our awesome list is empty. So now we are adding the previous index found plus new index found. And okay, we have this number 36. So we are concatenating, we are taking substring of this text. So you see here we have this lorem ipsum, and we will cut it till this first match the. So we have cut it. So here starts a new part of text, and we are finding the new index here. And now we're starting a new loop iteration. So previous index is not known until now, when we will check if we have some values in our awesome list. So here we have some previous values. So we have value in our awesome list. Here's now 36. We are getting this value and calculating this to a found new one. So now, so the previous was 36, next is 59. So calculating them together, we have this 95. And again, we are cutting our text till from beginning till next the match plus one symbol. To the next iteration. So here our awesome list contains two previous found indexes, absolute indexes from the original text. We got the previous and summing this up with a new relative index. Now we have here inside in our awesome list next absolute index. So in our awesome list we are storing absolute indexes from original text. But here in loop we are getting relative indexes of this match, but we are putting them in awesome list by getting previous absolute value plus new relative. And after we have done all this, we have our awesome list with all calculated absolute indexes. And here we have print self function that brings this all on a screen. So please rewrite this example by, so yes, so we have completely reworked this. Let's last index. So let's it's better even to rewrite this completely because most probably we will get some mistakes. So please rewrite this previous count with this. If you have this size and get, did you have, so you can take the last version of awesome list from a GitHub. So we have done this on a previous lesson. So we have implemented these functions. So maybe you do not have these functions implemented. You can take the latest version from GitHub. So yes, here are the results. So here's the question. Why we don't need this check? Why can't we just take the latest element from this la this latest element after calculating this index? Why do we need this check? So we need this check because if our collection is empty, this size function will return 0. And 0 minus 1 will cause us that this last index will be minus 1. But we cannot get from array or collection with index minus 1. So here we're checking actually, did we have some previous calculated value? So if not, let it be 0. Uh, so so did you got this whole example uh, rewritten? So I understand that this became much more complicated than I thought initially. Uh, so my idea was that you will find these positions and put them in our awesome list because if we have created some awesome things, it's a good idea to use them. So okay, let's. So I will put this code in a GitHub, and so you can debug this once more. And if it is now, let's wait 1 more minute until it is rewritten, and then let's start a new topic. So this one was uh, uh, much more extra than I thought before. I'm really sorry about that. Uh, but well, but this is a good way to use what we have already done before. Okay, so now, so I'll show this little bit more time. Now let's create here inside OP package a new package, and let's call it collections. And there inside a new class called try list with main function inside. And please give me a sign when you have done this. So new sub package collections and a new class called tryList with main function inside. Okay, so as you have seen just before, this awesome list was very useful here when we did not know previously how much matches we will have. So uh, until we have some matches, we're just simply putting them inside our collection, and this collection just uh, resolves its inner array size and so on just by itself. So once we have written this class, we can simply use it and do not think about this all this complexity with storing elements inside array. So we do not know initially how big this array will be. So we have this special wrapper and around array, and putting these elements uh, when we when we got some new. So uh, we here we have used this strategy divide and conquer. So here we have divided this all complexity uh, uh, into independent parts. So we have declared this class that holds all the logic about storing elements in a comfortable way, and all the rest part. So uh, actually, this awesome list is something really same that our Java uh, already has. So collections in a Java, that's a very important part of whole framework. It is very convenient way to work with data. So in production systems, you will uh, work with some kinds of collections all the time. So here are three. So let's start from the general theory. Collections, it's a way how to store and process some data. So from the first on the first part, storing data and then processing the data. So getting values and manipulating with the data. But the main is about storing and getting data. So here are three types. Here are three general types of collections. So sets, lists, and maps. So let's start from a list because we have already done some. So what is the list? So list is such data structure in not only in Java. So we have lists in most high-level programming languages. So list is a data structure that can that holds the data uh, in an ordered way and allows duplicates. So lists allows duplicates and or ordered by uh, by input. So exactly like we have here before in our awesome list. Once we have added value in it, it is stored in its position. So uh, that's like first in, last out. So once we have added value to collection, it is stored in the same place. And when we put another element in collection, it's the place of previously inserted is not changed. So now let's create a a list that is written that is done by Java developers. So you will need to import these collections. So they will be stored in Java util array list. So the same approach like you have done with scanner. So when IDEA asks you to import this class, so just press Alt Enter and this will be automatically imported. Let's call it list and new array list. Okay, like this. So please rewrite this comment and this declaration. So here the difference between our awesome list, okay, the name. So have you imported this? Imported. So idea may. So if you have this in red, so put pointer here and wait until idea will ask you to import. So here you press Alt Enter, and this class will be imported. If this doesn't happen, write this import java.util.arraylist manually. So what is the difference between our awesome list written before and this one? So name array list, and here we have this extra triangle quotes, triangle brackets, and here we write the type of values that we will store. So what we will, so about these generics and why we have here, why do we have something here between this triangle brackets and here no? That's a very big topic. We are talking about this in main bootcamp. So for now, um, the important part when we are declaring collections for lists, here in the data type, so here this declaration, we write what we will store inside. So we here we write not int, not this, but integer with big letter, because we cannot store primitives inside collections. We can store only objects. So integer with big letter and with full name, it is it's an object that that works just like primitive integer. So so actually they works in very similar manner. So we cannot, but just because we cannot store small int in our, we cannot use it as data type in our list, we have this special integer. So most of these Java primitives are really same. So long with small in lowercase and long capitalized here. So the only difference is with int and integer. So that's just you need to remember. So here's the declaration of list. So most probably you will use array list, and here you specify what you will store inside. If you will store ints, here you need to write integer. If you want to store strings, here you write string. If you want to store here cats, okay, not a problem. Let's store cat here. Okay, now let's talk about integers, but let's talk about them after a break. So let's make a break late until 2015. Okay, let's do a break now and then continue.